This is an interesting topic. So when we start talking about acids and bases, and we've identified a lot of acids, right? They start with hydrogen, a lot of bases that have nitrogen in them or hydroxides in them. Sometimes things that you might not expect have acidic or basic properties. Actually, most things are not neutral, right? So if you have a substance and you test the pH of it, but it doesn't actually have an acid or a base in it, why does it have a pH that's not 7? Okay, and we're going to talk about that. The reason being, some solutions have acidic or basic properties. Some of them are neutral, of course, but it's because of all of these conjugates. So this is where conjugates are really important. Okay, so if I look at this, I'm trying to talk about some solutions that are acidic, basic, and neutral. So the pH of salt solutions. So this is all ions, it's all conjugates. So NaClO, if I actually take the pH of this, I get something that is basic. Okay, NH4Cl, I take the pH of this, I get that it is acidic. But NaCl, that is neutral. Why? Okay, so it has to do, like I said, with those conjugates. So in order to determine if something that has an ionic compound in it is going to be acidic or basic or neutral, we have to write what are called hydrolysis reactions. Hydrolysis. Hopefully hydrolysis reminds you of water. That means we should react with water and see what we get, okay? So if a reaction with water yields something acidic or a reaction with water yields something basic, that's where the acidic and basic come from. So NaClO, when it's put in water, must give off something basic. NH4Cl, when put in water, must give off something acidic. And that's what I'm going to talk about, okay? So we have to write the reactions with water in order to figure this out. So I'm going to show you one of those reactions with water from one of these above. I'm going to use sodium, what is that, hypochlorite, NaClO, okay? I'm going to use the ClO because that's actually the thing that makes basic. So we know ions break into two ions. You always get a positive one and a negative one. So you kind of have to think about both. Does Na plus affect the solution? Does ClO minus affect the solution? Well, according to what we know right here, NaCl is neutral, so Na plus must not do anything. So that's why I'm going to focus on the ClO minus. All right. So reactions with water. This is our example. Okay. I would put ClO minus. Again, you want to look at each ion separately. What does it do in water? Well, could it gain a hydrogen or could it lose a hydrogen? Well, it can't lose a hydrogen. It doesn't have one. So it could gain one. And what would happen? I would end up with HClO. That looks like an acid. And OH minus. Okay, so this potential reaction does happen. If you look, this is actually a weak acid. All right, meaning this was its conjugate. This was a weak base. That is why it has basic properties. So what we're going to do every time we have a salt and I want to know the pH or if it's acidic or basic, we have to look at the cation or the positive thing and the anion or the negative thing. Okay, so break it into its two ions, look at those ions separately. What happens when we put them in water? Okay, so I like this little flow chart. It's going to kind of walk us through cations if they're in group 1 or group 2 of the periodic table. Okay, meaning alkaline metals or alkaline earth metals, all right? If they are, then they don't do anything, okay? They don't hydrolyze, don't affect pH. Don't affect pH, all right? Reason being they are conjugates of strong bases. You don't have to be able to explain why they don't, but if I put Na plus in water, well, it doesn't do anything because it's a conjugate of sodium hydroxide, which is a strong base, so it doesn't actually do anything. All right, so if it is in a group 1 or group 2, meaning alkali or alkaline earth metal, it will not affect. So if I look back up at my examples, Na plus is in group 1 on the periodic table, so it does not affect pH. Now, if my cation is not in one of those groups, it has the potential to affect the pH. So that means like it might be acidic or basic, A or B, and you got to check. Okay, so you have to write out its reaction with water. Now, I'm going to switch to anions. Okay, so the negative things. When you look at the negative thing, if it is something that is found in a strong acid, meaning those 6 that you had to memorize, okay, if it is, it does not hydrolyze, meaning it doesn't affect pH. Okay, so is it found in a strong acid? Here's an example, Cl minus. Right? Is that found in a strong acid? Well, yes, it is in HCl, which is a strong acid. So that means it's not going to affect pH. Reason being, it is conjugate of a strong acid, so it doesn't really do anything. All right, so again, up here, that's why chlorine, Cl, doesn't affect the pH. Now, ClO, you might be like, well, there's Cl in that. No, that's ClO. That's the ion is ClO. Right? That is not in a strong acid. ClO4 is, but not ClO. So that one does affect pH. All right, so no matter what, if it is an anion that is not part of one of those 6 strong acid, it will affect the pH, okay? It will be hydrolyzed, and you're gonna get something that ClO ends up being basic. It makes it basic. All right, so we're gonna write out these equations. We're gonna talk about Kas and Kbs, how all of this is related, okay? And which ones are neutral, which are acidic, which are basic. When you look at a compound, you should be able to be like, that's acidic, that's basic, that's neutral. It does take practice, all right? So which things are neutral according to the rules that we just went over? So we're gonna make kind of like groups, all right? Anything that is a conjugate of a strong acid or a strong base, okay? If you look up at our little flow chart, if it's in group 1 or group 2 for the cation, or if it's part of a strong acid, it is not going to affect the pH. Bless you. Okay, so these are the conjugates of strong acids and strong bases. So if you know your strong acids and strong bases, which you should, you will be able to tell. Okay, so for example, NaOH is a strong base. I know when I put this in water, I get Na plus NOH minus. Full forward arrow does not go backward, meaning Na plus can't do anything. It cannot go in the reverse direction. It cannot react and act acidic, okay? Same thing, okay, with HCl, all right? It breaks into H plus and Cl minus. Cl, full forward arrow. Cl minus cannot go backward, okay? Meaning when I put these in water, okay, so those are what they do in water. In water, I told you we have to look at the hydrolysis reactions. This completely breaks up. I put Na plus in water. It can't do anything. Okay, it can't go backward. It can't make NaOH because it is a strong base. Same thing if I put Cl minus in water. Okay, it can't make HCl because HCl is always going to break up, so you get no reaction. Those are the things that are neutral. Okay, so if your ion is part of a strong acid or strong base, not going to affect the pH. Okay, so what things are acidic? Okay, so if I look back up at my little flow chart here, what makes something acidic? Okay, well, if it's not a group 1 or group 2 and it's a metal, we're going to talk about those in a minute, or if it is a conjugate of a weak base. All right, so here's my example, right? NH4 plus is my go-to example of a conjugate of a weak base. That's what's going to make it acidic. Okay, so which subs are acidic are going to be things that are conjugates of a weak base. All right, if you look at my examples here, neutrals are conjugates of strongs. Okay, if it's acidic, it is a conjugate of a weak base, and you guessed it, if it's basic, it's a conjugate of weak acid. Okay, so remember that. I'm going to talk about this picture above it in just a minute, but those are the important things to remember. So I'm going back to acids here really quick. Okay, conjugates of a weak base. For example, if I have NH4 plus, which is a conjugate of a weak base, and I put that in water, what happens? Well, it's going to donate its hydrogen, right? It's not going to take another one on. You've never seen that before. NH5 2 plus makes no sense. But NH4 plus will give off a hydrogen. You can end up with H3O plus and NH3. Okay, this is what happens when you put NH4 plus in water, which is why you get an acidic solution. So that is why in my examples above, this one is acidic because this can react with water and make H3O plus. Okay, so the reason being this equation I just wrote. Okay, so that's how I get my acid. Now, I'm going to talk about those other metals, okay? If you have other metals in there that are not group 1 or group 2 acidic, be hydrolyzed. Okay, so what can happen And you don't have to be able to draw this out. We're going to talk more about this in a much later unit. But if you have something like aluminum and water, a bunch of waters like to attach to aluminum. So if you look at this, this is aluminum with 6 waters on it. Still has its 3+ charge, but those waters like to kind of attach to it because it's got all those electrons on the outside. Okay, so then what happens is these electrons kind of attack this hydrogen, it takes one off, and you end up with aluminum with 5 waters and OH minus, and then this free H3O plus, which makes it acidic. Okay, so sometimes you will see these acids, so metal cations. This is the other thing that can be acidic, is metal cations that are not in group 1 or group 2, and not 1A or 2A. Okay. So this can happen as well. So if you see a metal cation, you should probably assume it's going to be acidic unless it's conjugate of a strong acid. Okay, and then bases don't have like this exception. All right, so which ones are bases? They're just conjugates of weak acids. Okay, there's not really another thing to talk about there. I am going to write an example though. What's a conjugate of a weak acid? Okay, well, acetic acid is usually the one I use for examples of a weak acid, HC2H3O2. So its conjugate is C2H3O2 minus, that acetate ion. Okay, what happens when I put it in water? Well, negative ion, the only thing it could do is take on a hydrogen. It doesn't have one to give off. Now, I know you might be like, well, there's hydrogens in there. Those aren't going to break off. Acetate's a stable polyatomic ion, all right? But you could have a hydrogen go from the water to it, and we could end up with HC2H3O2, that weak acid I was talking about, and OH minus. So this can happen, which is why we see these being basic. Okay, so that was our example. So that's how you determine if it's going to be acidic, basic, or neutral. So I might ask you a question on the test that says, is this ion acidic, basic, or neutral? And you should be able to answer that based on, if you broke it up, can this thing act acidic? Can this thing act basic? Okay. Question you might be asking is, what if they both affect the pH? So what if I'm going to go back up to my examples. What if I had something that had NH4 plus and ClO minus in it? I'll talk about that one in a little bit. Okay. All right. So back down here, I can also ask you to find the pH of these. This is where this whole relationship between Ka and Kb comes in. All right. So what is the pH of a 0.10 molar NaClO solution? Okay. You might look at that and be like, that's not an acid. It's not a base that I know of. So in that case, you need to break it into its ions. Be like, okay, Na plus, does it do anything to affect the pH? No, it doesn't, because it is the conjugate of a strong base, NaOH. ClO minus, does that ion affect the pH? Well, it's the conjugate of an acid, HClO, but not a strong acid. So yes, this is going to affect the pH. Okay, that ClO minus ion. Okay, so what you need to do is write the hydrolysis equation. Okay, what happens when this is in water? Okay, so I'm talking about solution. So it's like, what goes on when this is in water? Okay, so I'm going to write ClO minus plus water. Okay, again, if you're not sure, well, it can't give off a hydrogen. It doesn't have one to give off, but it can take one on, so it can make HClO and OH minus. Okay, so I have this nice equilibrium equation. It has hydroxide in it, so if I can get to the equilibrium amount of hydroxide, I can find POH, pH related, right? So I'm just going to go ahead and set up a nice table. Okay, so I have a 0.10 molar of NaClO. So that means I've got 0.10 molar of both of those ions, because there's only one ion in each compound. Okay, so that means I started with 0.10 molar of that. Nobody cares about water, none of this. We're going to get it to equilibrium, and then I can look at that whole pH thing. All right, so this is going to be minus x plus x plus x, 0.10 minus x, x, x. Awesome. Okay, next thing. I need to write out a K equation. All right, can I do that? Well, I sure could. Excuse me. So I've got K, and what is this acting like here? Okay, is this like an acid, or is it like a base? Well, it's making hydroxide, so this is a KB equation. Now, if you're not sure it's AA or KB, just look, hydroxide, KB equation. But this is exactly a KB equation that you would write if I said write the base equation for ClO minus, all right? So it would be, right, concentration of products, so that's going to end up being x squared over 0.10 minus x. Awesome, okay? Now, do I know the Kb value? Well, no, I don't. I can look up the Ka value of its conjugate. I can look up the Ka value of this guy. Okay, the Ka of HClO is 2.9 times 10 to the negative 8. Okay, so that means that the Kb of ClO minus is Kw, remember, equals Ka times Kb. So I can do that is 1.0 times 10 to the negative 14. That's Kw over 2.9 times 10 to the negative 8. Right? So that means that Kb is, let's see, I did the math there, 3.4 times 10 to the negative 7. Okay, so Kb of ClO minus, I can now plug that in over here. So I would do 3.4 times 10 to the negative 7 equals x squared over 0.10 minus x. Yes, you can drop that minus x. Okay, that's going to make your life a lot easier. Drop this. You get that x is 1.8 times 10 to the negative 4th. Okay, well, how does that help me? I'm trying to find pH. So right here, I can find POH. So POH is the negative log of that number. Okay, so POH is 3.73. So pH after I subtract from 14 is 10.27. Okay, pause. Does this answer make sense? Well, ClO minus is the conjugate of a weak acid. So that means this solution should be basic. Is my pH basic? Yes. Yes, it is. So you probably did this correctly. All right. Now, try the opposite with example number 9 with a conjugate of a weak base. Sorry, I have to watch my wording there. All right. So give that a shot. Okay. So if you got 5.12, awesome job. I wrote by what happens in water, so hydrolysis equation for NH4+. Okay, I noticed that was the conjugate of a weak base, NH3, which is something I can look up, that 1.76 times 10 to the negative 5th. Okay, so I wrote the hydrolysis equation. That is a Ka equation, right? It's making an acid. So I can find the Ka from NH4+. I can do 1 times 10 to the negative 14th over 1.76 times 10 to the negative 5th and get that the Ka is 5.68 times 10 to the negative 10th. So that equals x squared over 0.10 minus x. Solve for x. Yes, you can drop that x, or if you have the solver button, you can leave it in. I got 7.54 times 10 to the negative 6th. Plug that in for x, which is H3O+, and I can find my pH. And you did not have to subtract from 14 because this was an H3O+. Okay, so they work the same. You just kind of pay attention to if it's an H3O+ and OH minus. Should it be acidic? Should it be basic? Ask yourself these questions and watch your equations.